Hey guys, so in today's video I'm going to be going over some more flashcards. In particular, we're going to be going over pandas, and it's going to be Anki. So if you've seen any of my previous videos, you'll see a lot of the same type of flashcards. And obviously the point of flashcards is to make sure that you remember something and you keep remembering it over and over and over again. Practice it. Um, but yeah, the reason I use the software, which is called Anki, is because my goal is to not necessarily memorize, but to know that there are specific ways or remember the vocabulary, um, and know that there just are different ways of using code, in particular with data analysis and data science. Um, but pretty much so that way I don't have to go and look them up anymore, and likewise, just so that way I'm able to retain them for the relatively long term. So with that said, we'll go ahead and dive into this flashcard. So with regards to this flashcard, we're working with the Titanic dataset, and all that it's asking is, what does the following do? So if we were to run titanic.corr, as well as titanic.survived.corr, and then enter titanic.pclass, what do you think would happen? So when it comes to .corr, I honestly wouldn't know the real answer to that, but what I would do is always just run the code. I do know, though, that we're going to be working with pclass and survived. So if we were to go ahead and see the answer, what it would return is a correlation matrix, of course. So correlation matrices, all you need to know is that the closer to 1 that a specific value is, the more correlated those two columns are. So as we see right here, we have survived and survived, which is 1. But survived in P-class is minus a negative value. Likewise, the P-class with P-class is 1, but P-class with age is another negative value. So the goal is, when working with data, to identify values in columns and identify the columns that are particularly correlated at a higher level to your target column. And then to kind of focus on the quality data from there. But obviously with more data, with acquiring more data, the correlation may adjust in the favor of different columns for your target column. So always experiment. Now, when it comes to survived correlation and Titanic pass correlation, so we had survived and then we had P-class. We see that there's a negative value, and the same negative value is shown here. So what you can do, or at least what this flashcard is showing us, is that you could go ahead and find the correlation between two specific columns. So if you wanted to, you could do titanic.survived, and survived will be the, when you're working with the Titanic dataset, the survived column is what you want to predict on, so it would be your Y. And I'm speaking about machine learning right now. So just know that your target column can go ahead and see what the correlation is with another column. So I'm going to go ahead and click good, and I'm expecting this to go ahead and show up in the video again. Next, when it comes to this question or this line of code, what would the output be? So when it comes to titanic.fair.comSum, what do you think it would be? Yeah. So all that really is going on with this is it'll go ahead and have the cumulative sum of all the values. So we'd start at 7.25, and then from there the next line would be 7.25 plus 71.28, and let's go ahead and see what that would be. So we'd see that 72.5 plus 71.23 is equivalent to 78, and then you go ahead and add another value. From 78 you would add 79 or 7.9, and then from there it'd be 86, and then 86 plus 53, and so on. But it's the cumulative sum, like it keeps adding up every row. So just know, I've seen actually a couple of dashboards that were created with the cumulative sum of like how much ad spend someone spent on either Facebook marketing or something else. I think it was Google Analytics. But I've seen this actually used in in actual dashboards. Although, yeah, mostly like with ad spend. But I'll just leave it at that. I'm sure you guys will also see it out in the wild. So dot comes sum. Kind of a, yeah, I'll leave it at that. So what else do we have? We have this. So what would the output be of Titanic.not.na.sum? So what I'm predicting will happen is, if you guys haven't don't already know the answer, is that Titanic.na.sum will go ahead and sum all numeric columns, and it will not sum nan or null values. So we're going to go ahead and run it. Let's see what the actual answer is. So it returns the character count. The character count? Does it though? I think it's the row count. That's what it should be, like the length of non-null values. Age has null values, thus less count than survived. So age has a nan right here, so we'd certainly see that survived would be less. So not NA is not the actual sum of the integers, numeric columns, but rather it's actually the sum of the length of rows in a data set, or specific values, I should say. So in case you haven't guessed, these flashcards are just as much practice for me as it would be for you. So I wouldn't claim to be necessarily a pro, at least with pandas, but with regards to many of the other, well, with regards to SQL, definitely. So let's go ahead and update this so I have it for future reference. So it returns not the character count, but it returns like the row count. The row count, or the slash the length count of non-null values. Cool. So that is row count. So this is row count. All right, that's good. Next, how can you locate a specific string value in a column? So for example, if you wanted to take this invoice data set or data frame, and if you wanted to go ahead and locate the type of meal, and then we wanted to locate like a AST in the column. So how would I explain this? So pretty much think of it saying if AST exists in any word or any value for this specific column, it would populate. I bet I'm still confusing a lot of people, but just know, if I was to write this out in code, what I would do is I would do invoice, type of meal, and then from there I would go ahead and do, I think I'd go ahead and use, I'm blanking, my mind immediately went to .isin, but I know that's not right. So what would it be? I think it would probably be between, or it wouldn't be between. It would be isin, or there's another column. But let's go ahead and see what the code is, and then I'll come back to this again. So .string, .starts with, or .contain. Okay. So this would be pretty much the output of it. And then this would also be ends with. So there would not be any between, but I'm curious if it would still be isin. So let's go ahead and run the code over in Colab. Now this will be a little bit different, so what I'm going to do is I'll just select the names. But let's go ahead and do data frame, which is our Titanic dataset. Let's go ahead and do name, and then str.isin. I just want to test this, isin, and then I believe it was AST. Run it. So we wouldn't be able to do that, but we could do ends with, run it, and then we'd see that it does populate. So this would be it. So either ends with, contains, or starts with. Is that the other one? Starts with, yeah. Ends with, starts with, contains. Okay, so that's kind of hard. I want to see that again. Next, this is looking like it's actually an answer, but how could you identify women, so females, that are below 14? So how can you locate individuals that are below 14, the age of 14, or women, females? So if we were to write this in code, what we could do is we do We could do female or women, I guess. That makes sense. Data frame dot sex equals to female. And then from there we could do age equals data frame dot age. I believe it was less than 14. And then from there, what I would do is I'd do women or age dot head, if I'm not mistaken. And that's what the answer would be. True, false. So in essence, yes, this is right. But let's go ahead and let's actually locate the specific value. So we've already run the code, so let's go ahead and do dot locate. And then it would be women, age, and I feel like I'm screwing this. Let's just run the code. So we'd want to go ahead and locate this one. I still feel like I'm screwing up. Okay, cool. So I got it. So what this returns then is individuals that are either female or younger than the age of 14. And it looks like that might be true then with this male part. So let's go ahead and see what the answer is. So with the below, what we would do is we could do what in essence I did over here. So mask 1 is what I put for women. And then we just did mask 1, and then that'd be heads, which would be true, false. And then from there, mask 2, titanic.age less than 14, dataframe.age less than 14. And then from there, we could do this, and this symbol, like the straight line symbol, which is above your return key and also above your enter key, just means or. And then also what it would be is it would be titanic.locate the or, as we see over here. So titanic or data frame dot locate, and then the or symbol. Okay. I definitely want to see that again, so I'll see that tomorrow. Now, yesterday we actually worked with this dot between dot isin. So for those of you that remember, what do you think? What do you think the difference is between dot between or dot isin? So if you've had to think or thought about it a bit, I'm thinking of British. If you thought about it for a bit, what do you think would happen? So if we use dot between, what would be the output? So if you haven't thought of it, it would pretty much just return values that are between two specific values. It would return rows as true or false, columns that are between the specific indicated values. Whereas isin would say we need to match specifically 1972 or 1996 or any other year that we add to the list. It just needs to match at least that specific value. So if we run it, we get to see, oh, well, that's lame. But pretty much the difference between them is between two different values. Isin, it needs to match the specific value. So I feel pretty good about that. I'm just going to click good so I could study it tomorrow. And then again, we're with the correlation matrix. So if you recall from earlier, what do you think the correlation matrix would be? If you can recall, like, why are higher values, aka closer to 1, important? So the reason that the higher values are important is because the closer to 1 that they are, the more correlated they are. And that also then means that if you're working with a specific value that you want to find, such as in a machine learning algorithm, you'll know which columns to go ahead and specifically target, and possibly which ones you should just drop. So it's just really, really important when working with and trying to find patterns in the data, as well as being able to identify better quality data that you should use for your machine learning algorithm. So .corr. And actually, let's go ahead and stop right here. From here, I'll go ahead and recreate some data, and I'll manipulate our other data frame, and then we'll go ahead and create a correlation matrix and actually create a heat map with Seaborn. So let's go ahead and jump into Colab. So now that we have our data set established for our Titanic data set, what I'm going to go ahead and do is we'll go ahead and just recreate the correlation matrix and then turn it into a heat map. So what I have in front of us is our data, and so if we wanted to, let's go ahead and do data.corr. Let's actually save this as a variable, so corr matrix, and let's go ahead and run corr matrix again. Let's go ahead and see what the correlation would be. So notice how there's a nan for body. In essence, I believe body is like a new column that was added to this Kaggle dataset, but I'm going to go ahead and just leave everything as is, so that way I don't really have to worry about dropping any of the values. So I actually created a little bit of a data set before where I did try to drop nan values and then just dropped everything. So rather than going through and just recreating it all I'm going to do is, for this video, I'm just going to create the heat map, and then next video or a couple of them later down the line when I do create the algorithm, like for a classification model, what I'll do is I'll go ahead and add like median or mean values, whatever seems right. But with regards to creating the heat map, what we're going to do is we're going to go ahead and import seaborn, so seaborn as SNS, and then from there, since we already have seaborn, what we could do is we could go ahead and also import matplotlib from import matplotlib.pyplot as plt, and then from there I believe I should be good. So we have our fig and our ax. We'll go ahead and equal the plt.subplot. Subplot, right? I believe 15 by like 10 should be good. So, and then what else did I do? So I'm trying to remember what I used to create from memory. So if we have our fig and our ax, what else was there? And then we also have our correlation matrix, which is already established here. So the last thing would be, I believe, just the heat map. And then from there, what we go ahead and do is enter corr matrix. And then from there, we could do cmap equals yellow, blue, green. Is that right? Or is it yellow, green, blue? And blue. That seems a little bit better. Let's go ahead and run it and see what the output is. So fig ax equals plt.subplots. Subplots. Looks like it's working. And then we'll go ahead and see like what the output is, but I have a feeling that I might need a little bit more information, at least. Oof. This is great. Good job. Okay. So let's go ahead and finish this. I have a feeling I might be forgetting something, so I'll go ahead and cut right now, and then I'll come back in a little bit. Okay, so I actually wasn't that far off. I'm surprised. I went to look at some of my older code for creating correlation matrices, but ultimately the only thing that I really ended up missing was actually entering the fig size. The rest of this we can honestly probably just get rid of and still run it. So let's actually comment these lines out, and then we'll go ahead and run the code. Never mind. Let's go ahead and bring those back in. And yeah, so this is what we'd be able to see as far as a correlation matrix, like in a fancier fashion. Let's actually zoom out. Usually zoom in so that way the code could be seen a little bit better. But as we see with this heat map, again, the most important columns are the ones that are usually closer to 1. And you see how they just pretty much align with wherever the other, with themselves, like usually they're the highest value. So correlation matrices. So today we went over pretty much dot between, dot isin, the or symbol, as well as the correlation matrix. Now the reason I'm going to go ahead and cut this video short is because over the days I've been kind of thinking like the reviewing flashcards is fine and all. I'm starting to really catch on, but I'm not sure. Well, I'm creating these as much for myself as I am for other individuals and other people to watch. So what I think I'm going to do is I'm just going to keep doing the flashcards, and I'm going to go ahead and finish creating up some of my other flashcards. But I think moving forward, maybe in a couple days, what I'll go ahead and do is I'll go ahead and create actually how to create a classification model. Maybe not beginning to end, not necessarily actually collecting the data, but just kind of working with Kaggles because it's just easy. And then from there, classification, regression, and then possibly PyTorch. But I also have some other projects that I really want to work on. So we'll just kind of play it by ear. Next time, in the next video, I'll go ahead and again start with Anki, and then I'll go ahead and probably just do some more coding, like try to recall everything that we've gone over in memory. So yeah, so I'll go ahead and end this video here. If you guys like, please feel free to book a session with me in Snugg. There I'm just doing pretty much data tutoring, so I'll go over the very basics of things with you, just go over any errors that you might be running through in your code. And likewise, yeah, I'll go ahead and end this video here. So thanks for watching.